Hello everyone, I am Sabyasachi. I am a data science and business analytics intern at the Sparks Foundation, and this is my first project, which is a stock market prediction using numerical and textual analysis. So, browsing through the code, you can see this is where I import all the models that I need. So, very basically, there are some things that I need like Math, Numpy, Pandas, SciKit Learn, Matplotlib, the text blob for textual analysis, Keras, and Beta Sentiment. This is all that I need for this project. So first you can see I am loading in my datasets, that is the stock prices CSV and the news.csv. Now these datasets are present online and you can also download them if you want. I have printed the first 5 values here, so you can see these are the first 5 values of them. And here also you can see I am renaming the columns as date, category and news here and putting the appropriate data there. Now after doing this, I am cleaning a bit of the data which is not present or support. I am sorting it also. So after being sorted, you can see it's sorted by index. And after this, I am storing the names of the city. So here I'm using regular expressions. So you can see I have imported regular expressions. I am using regular expressions to store the city data, that is the cities that these name of the cities. As you see, after extracting city data names, I have all the names of the city in a separate column. Now after doing this, I am actually pre-processing the thing. So you can see in pre-processing I am basically taking the date format and putting it in proper format. So first comes the year, then the month, then the date. So in that format I'm putting both of them. So both the news and the prices are converted to that date time format so that I can later merge them to create the hybrid data set. Now firstly I am plotting the prices of the stock. So you can see this is the original prices of the stock that my CSV has given me. Now I am storing the closing stock data, closing stock prices in. I am making a new function which will help me store the new dataset values, and then I'm using some functions to actually store that data. Now here I'll do some data normalization. So you can see I'm using the min-max scaler and fitting the data into that. I'm also splitting the train size and the test size and actually splitting my data set from my second data frame. I'm also doing some other normalization stuff so that it helps me later when I'm doing the analysis. Now here I am doing the Lstm neural network model where my epoch is 500 and my batch size is 10. So as you can see, this is the epoch that runs for 500 times. I'm not running it now because running it now would actually take a lot of time. So I've already ran it and it is here. So after that I'm making predictions. So as you can see here with the predictions, I have the train predict and the test predict, that is the predictions on the training dataset and the predictions on the testing dataset. Now these will give me the values. Now after this I am actually inverse transforming the datasets so that I can actually plot them into the graph. So I am shifting the train predictions and the test predictions and then plotting this. So this red line actually represents the training data set, what my training data set has actually predicted. And if you compare that with the blue line, I don't think you can see the blue line because the training data set has performed exceptionally well. It is exactly over the blue layer. In these small places you can see there is a bit of the blue coming out. And my testing data set has also performed very well. Only in this top part you can see there is a bit of offset, but except that everywhere it is perfect. Now I am taking out the RMSE, that stands for the root mean square error. So you can see on the training data set there is about 0.50, that is 50% RMSE. As you can see, this is hardly off the track, and On the testing dataset, I have 1.25 RMSE, so it is a bit of the track, but it's still very good. Now, with that being done, I am moving on to the textual analysis part. Now, in the textual analysis, I am taking out the headline texts of every city, the number of headline texts that every city has. So this is the top 15 headline texts that I can have. Now I'm also plotting them. So as you can see, Nagpur is the highest, and there is Vadora, there is Vijayawada. These have the lowest among the top 15. Now I'm using this to actually do the sentiment analysis of the headline text. As you can see, I have three values: negative, positive, and neutral. So I'll do two things. I'll have the polarity and the subjectivity. So here I'm taking out the polarity, as you can see. Now these values tell me what is the percentage of the people who are actually towards the headline, that is they approve of it. So positive headlines, there is about 30%, the negative headlines is around 12%, and the unbiased, that is neutral, is around 58%. So plotting this in a pie chart gives us this value: 58 is neutral, 12 is negative, and 29, almost 30%, is saying that they are positive. Now with these two being done, I am moving on to the hybrid model that will help me for stock price prediction. So in the hybrid model, the first thing that I need to do is make the hybrid data set. So I'm again loading the data from the original CSVs. After that being done, I'm making the hybrid data set here. I'm performing the date time format also. So I'm converting the dates that are given here to the date that I actually want. So after that being done, I'm moving on to the hybrid data set. So in this hybrid data set, I am merging the thing. So I'm merging the DF news, that is the news data set, and the data and the prices data set on the basis of the date. So the ones that have the common date will only get merged. Okay, so you can see these dates that are common are being merged. Now after this being done, I am performing sentiment analysis on the hybrid data set. Now after running sentiment analysis, you can see in the sentiment column we have neutral, negative, neutral, neutral. We will also have positive. So after doing some quick subjectivity and polarity scores for everyone's, so you can see we have the subjectivity scores here and the polarity scores here. Now we'll plot the scores. So I'm plotting the polarity first. Now this is how much polar the news is, and this is how much subjective people are towards it. Subjective it is. So now after this being said, I am performing the actual sentiment analysis that will give us the value if somebody is positive towards it, negative towards it, or whatever. So after doing that, I am storing it in the hybrid data only. So I'm actually reusing the hybrid data set to actually add some columns. You can see we have negative, neutral, and positive. Now these are the columns that I'll be needing, and I am actually renaming the positive column here to label. So after doing that, you can see I have the neutral, positive, and label. I'm not having any useless columns here. I'm only having the ones that I require. Now again, I will use multiple models to train and test my stock price performance. Now I am dividing the data set, as you can see. After dividing, I'm splitting the data set also. After splitting the data set, I am doing some filling, that is part of the data pre-processing. And now I'm using different models to actually check what is the accuracy I'm getting with different models with the stock price prediction. Okay, so firstly I'm using the Logistic regressor model. It is giving me an accuracy of 0.80, which is 80%. It is giving me 80%. Now next I chose to use the random forest model, which is giving me an accuracy of 78%. Next I used the decision tree model, which gave me a worse accuracy of 75%. Next I used the LDM, that is the linear discriminant analyzer model. It also gave me 80%, around 80%, the same as my Logistic one. And my AdaBoost actually gave me, now next I moved on to AdaBoost. Now AdaBoost gave me 82%, which is the best among right now. Now I could have stopped here, but I also wanted to try out the Logistic gradient boosting model. So with the Logistic gradient boosting model, I got 82.2%, which is like 0.2% more than the AdaBoost model, but it is still more. So at this point we can say that our gradient model has given us the best score till now. So you can see I'm plotting all the model accuracies. It is very close because it is around 0.5 up down, plus minus 5 up down. So as you can see, my gradient model and my AdaBoost model are almost same here, but this is my gradient model is 0.2% more, so it is still more. So I'm saying that my gradient boosting model has done the best work. And as you can see, I'm printing the max accuracy and the model that has the max accuracy. So my max accuracy will be 82%, 82.2%, and my gradient boosting model will do the best. And this model will perform better to any analysis and prediction on the stock price or performance than other 5 neural network models that I used. So this was my project. My project is also hosted on my GitHub. You can see it. It is github.com/Sabyasachi Seal/stock market prediction. So I have explained everything here, what I've done. You can also find the source code here. And that was it for me. Thank you.